Hello, grade 7s. Okay, I'm just going to try and show you a video clip of this, but I've been experiencing difficulties with uploading videos, especially which are very long. So I just took the liberty of drawing again the diagram as to how you will have the setup of the investigation. So what you have, the key things are going to be your power source, which is going to be your battery there. So I chose a 1.5 volt because that's very easily accessible. And then you have your connectors or your power conductors right there. And here, this is an example of a lamp, like the one that you find at home. The lamp holder and a lamp, you connect to that. And then here are going to be, again, your leads from there, such that if I just put these two together, the lamp will light. If I just put those two together, the lamp will just light, because naturally that's how a lamp lights is. All it needs is just a battery. But then for this particular investigation, what we're going to do is that we are just going to leave it open. That's the gap that I was talking about. Now what this gap then ensures is you will take your material, all right, which we say it has to be of the same thickness. Okay, it has to be of the same thickness and the same length. So the length has to be the same, and the thickness also has to be the same. And that's assuming that all your conductors are going to be circular. But what we want to do is we want to try and keep this constant. So these are the two things I was saying that we need to make sure that we keep constant. There's two here. And at the same time, this also needs to be kept constant. So those are three things all together. So what you do is that you put this part here, this in there, and then you put that in there. So what you end up with will be your conductor like that. So if your bulb lights, okay, if your bulb lights, it means that this is a conductor. But then if your bulb does not light, all right, my bad there. But if your bulb does not light, then it means that this will be an insulator. So it's not really going to determine exactly how good a conductor it is or how poor a conductor it is. It's more or less just to say which materials are conductors and which ones aren't. Because when we want to get into more detail as to what is a good conductor, what is not a good conductor, you would need something more specific. You will need to use meters, and you also need to check, for example, brightness of the bulb. If your bulb is very bright, then it means that your material is actually a very good conductor. If a bulb is dim, then it's actually a poor conductor. If a bulb is completely off, then it means that it's not actually a conductor, it's just an insulator. So all those factors have to be taken into consideration. But in this case, I believe it's only asking you to just find which materials can conduct and which ones can not. Even if they're poor conductors, they're still conductors. And if they're poor insulators, they're still insulators, all right? So you're just determining what materials you used and whether that material will be a conductor or not.